Welcome to our first online lecture for AEC 270 Heavy Methods of Construction. In this class, which is taught asynchronously as you know, we are going to talk about a very important application in construction, which is the use of heavy equipment to perform construction tasks. Now, we've already taken light construction methods, so you've seen things like a hammer that you hold in your hand. You probably know what a shovel is. You probably know what a rake is. And all of these tools can be used by hand. They operate on one person power, which is not very much, and they are used to move soil, move concrete, drive nails, drill holes. You can imagine the number of things that you can do with hand equipment. Heavy equipment takes advantage of our ability to convert fuels into power. Remember, power, from your physics, is the ability to do work. And work is a force moving through a distance. Now, there are a number of ways in which we can get power to do more work than we can just with human bodies. And there's the two methods of providing that power. One is to burn fuel in an engine, and the second is to use electricity in an engine. We get these two to work, and they although we talk a lot about electrical equipment these days, although we think that it's a new idea, but electrical driven equipment has been around for a long time. Many electrical cars where we took a battery and connected it to a dynamo or a motor, which is a series of magnetic fields that rotate inside fixed magnetic fields and are forced to rotate by the changing current, and we can then drive a shaft. Similarly, if we burn fuel, we can then convert that fuel into useful power to turn a motor, whatever that motor looks like, which turns a shaft. Now, we can also use internal and external combustion. And in your Suez Canal assignment you've done, they talked about using steam. And in steam, we use an external combustion. We burn coal or wood or whatever. You take that heat, we heat water, we use that water to become steam. We take that steam, we use that to turn a turbine, and the turbine turns a shaft. And so in an internal combustion engine, we have a fuel that drives a pistons, which turns a crankshaft, and that shaft then rotates, and we know how to, once we have a rotating shaft, we know how to do all sorts of things with that. We can drive a pump, we can drive wheels, we can drive a pulley that will, or a rack that will wind and unwind a cable. So we can do all sorts of things with this turning shaft, and it has been around for quite some time. In the early 1900s, a gentleman in Germany by the name of Otto developed the gasoline engine, and it was decided that it was too important an invention to simply patent. And so we have gasoline engines that are made widely available nearly simultaneously. A diesel engine is developed by, that's not surprisingly, diesel in Germany. And this uses a diesel fuel or diesel oil, and it burns that oil in an internal combustion engine, all of which we do to turn a crank. At the end of the Second World War, the Eisenhower administration decided that they would build the Interstate Highway Program. And this was a major expenditure of public funds. And this expenditure of public funds required us, as a society, to develop ways of doing construction that were different from what we had done before. We had a number of changes. One is the torque converter, which allowed us to rapidly take power off of a rotating shaft. The second is the power shift transmission, both unfortunately developed as a part of making heavy vehicles that could do things during the war, allowed us to have a front end loader, right? So a front end loader, which is something at the front of the vehicle, as opposed to the old dip shovels, which were at the time were the method of using a shovel back and forth. This is much more efficient. There's three large changes that occur during this time. The first is high strength steel. High strength steel allows us to build lighter vehicles that are just as strong as lower strength steel. As a result, the machines would go, for example, a truck capable of carrying 40 tons of soil in 1939 has a weight of 25,000 pounds. By 1950, same vehicle, same capacity, has a weight of 16,000 pounds. If you think about the way in which we move things around, this reduction in weight of the vehicle is significant. It means that more power for a given engine is available to move the stuff because you don't need as much to move the vehicle itself. The second, nylon corded tires. Tires are a very important material. We would have a very difficult time if we only used rubber tires, because rubber is very elastic. And so what we would do is we would build many plies or layers of rubber into the tire. And so you've probably heard this on ads, you know, a 5-ply tire is 5 layers. What we could do if we put in layers of nylon, which was developed as an alternate fiber during the war, we can decrease the total thickness of the tire, and therefore we can decrease the amount of heat that is developed. And so for a given tire, it has considerably less thickness, less carcass, but it is still going to run. If we run cooler tires, we get better traction. So the tires can be used more efficiently. So we have lighter tires, which is good. They're much stronger, which is very good. And they run cooler, which means we get better traction. Finally, we have high output diesel. And almost all off-road construction vehicles that are doing work on construction sites today are running diesel engines. The compression can be raised, And some of you may not know the big difference between a diesel engine and a gasoline engine. A diesel engine has a glow plug, not a spark plug. Diesel fuel will not burn spontaneously the way gasoline does. It only burns under pressure. So they find ways to get 10 to 15% additional horsepower out of the vehicle. And so we should probably talk about what we mean by horsepower. And we'll do that in our next little lecture. But what this allows us to do is increase our flywheel horsepower. If we attach to our rotating shaft a wheel, which is moving or flying, we have a wheel, and do a better drawing. If we have a flywheel, this is a wheel that we're rotating with our shaft, the torque is what we can take off of this rotating shaft. So you can imagine it turning a belt. You can imagine it turning the transmission in your vehicle. You can imagine it being used to power a pump. And all of these things increase our flywheel horsepower. Over the past century, we've developed machines that can do almost every task you could consider on a construction site. They can dig, they can pump, they can move over a level terrain, they can move over unlevel terrain, they can push materials, they can pick up materials, they can deposit them into trucks, and the trucks can haul materials across the soil. And in general, there are refinements going on, but there's no real new innovation in the machines. What is happening to us are three things over the next 20 years. The first is the level of control. And this is important because more and more these machines are becoming automated. They're self-controlling the same way a car that drives on the road or that is a self-driving car. You can have these machines that are able to tell you where they are, what they're doing, how much fuel they're consuming, how well their filters are doing, and more importantly, you can download into them the plans. And if they know where they are and they can read the plans, then they don't overcut or undercut. The second is more amplification of human power. So our amplification of human power, when I was your age, which was about 30 odd years ago, they still had an awful lot of muscle power was required to run the machine. To change gears was difficult. There was an awful lot of just heavy lifting. And so you would see the same burly individuals with big muscular arms were operating vehicles. Today, everything is done by wire. You can operate things with a joystick. There's no physical requirements at all. And the third is that information processing. Where is the vehicle? What's it doing? Is it having a nice day? How many sandwiches did the operator have to eat? All of these things can be monitored and you've probably heard of it in the Internet of Things. So we can keep track of what our equipment is doing and various other things. So what the purpose of this course is to teach you the how and why of using equipment in construction. And most construction, other than residential and light commercial, will require amplification of power. So our next lecture is going to be talking more about what vehicular power is and how we measure things.